I'm sure most of all y'all know me already. I have a fellow Texas Tech Red Raider giving a presentation for us this morning, Matt Stevens with Sika Corporation. The good old, we were having a conversation this morning, and I was telling him back in the late 70s, my father was a framer, and I remember just loving to take those plastic cap roofing nails and hammering on the Armax on the outside of the studs. And to think that back in the late 70s, and I'm not even sure why my dad chose this product then, because he's certainly not a green type person at all. But we did cut-in bracing for structural and wrapped all of our homes with Armax half-inch polyiso, and it's really the only way to go if you want to stop that thermal bridging and get a continuous insulation. But I don't want to steal Matt's thunder. Matt, I'll go ahead and turn it over to you. Tell us a little bit about yourself, and the floor is yours, good sir.
Excellent. Thank you kindly for the introduction, Jason. My name is Matt Stevens. I'm the building enclosure and architectural consultant with Armax, which is a Sika company. Today we're gonna talk about Polyiso, the next generation air and water resistive barrier. Certainly many folks are familiar with Polyiso, especially in roofing applications. And even like Jason mentioned, it's been used in wall applications for many decades, but certainly with the code changes in the last decade, has certainly become more and more predominant. And, you know, Jason, one of the reasons why you all might have used that back in the 70s is OSB and plywood could have been at a peak like they are today. So we'll just a quick little history on Sika. Over 100 years old, 25,000 worldwide employees in 100 plus countries, 300 plus plants worldwide. So very, very global company. They really want to be an entire building envelope group. So we've got everything from concrete additives, which can be in your foundations and such, waterproofing, both below grade as well as above grade, roofing. Many folks are familiar with Sika Sarnafil roofing, building finishing. They acquired Parex in recent years, even some interior products with resinous floorings, sealants and bonding, refurbishment projects, and even some of the vehicles you drive may have Sika in them. They're very active in the automotive, RV, and marine industry. So enough on Sika. We'll get back to the meat and potatoes here. Polyiso, the next generation air and water resistive barrier. For anybody on the call that is interested or needs it, this class or this presentation is both an AIA accredited presentation as well as an IBEC approved course. So if you need certificates or credits for either of those, please let me know. I'll throw up my email address, stevens.matt@us.sika.com, or give me a call. I will answer. So just don't call me now.
and for the ICC CEUs, it's standard process, everyone. Kathy will send you a course evaluation. Just fill out the course evaluation and we'll get you your ICC CEUs.
Perfect. So we're going to throw this up. Jason's going to send out a copy of the presentation. Feel free to utilize it internally, but if you do want to utilize it for anything, outside of your organization, just let us know. More than likely won't be any issues, but you can't see me live today, but that is my doppelganger there, Al from Home Improvement. If I wear a plaid shirt, I get asked all the time. So like I mentioned, this is an AIA approved course. So if that applies to you and you need AIA credits, please feel free to contact me and we'll make sure you get credits. And if you're an IBEC professional as well, we can send you over a certificate for that also. So some of the learning objectives today, we want to understand how building envelope design can contribute to building longevity as well as sustainability, and make impacts on the building being more energy efficient, increasing the indoor air quality, as well as occupant comfort. Learn about how Polyiso, specifically foil-face Polyiso, can provide the air and water barrier in addition to being the continuous insulation, and also meet NFPA 285 wall assembly testing. We'll go over that more. Discuss some of the benefits from incorporating the foil face polyiso in specifically steel stud construction, but most of these concepts can be applied to mass wall or even wood framed construction as well. And we'll identify some key properties of polyiso, the associated components that allow it to be that air and water barrier, and really the optimum choice for energy performance and design efficiency. So building one, or section one, building sustainability and longevity. So probably not too often you're working on projects that are temporary in nature, maybe something that's going to go up during a construction project, or maybe a fair or an exhibit, 10 years or less. Not so often. Usually as professionals in the building world, you're looking at least a medium life building, 25 to 49 years. A lot of industrial buildings or some parking structures fall into this category. Now, if you decide to drive downtown this weekend and you realize you parked in a parking garage and it's 50 years old, don't freak out. These are just some general guidelines. Buildings are a lot like cars. With proper maintenance, they'll last a very long time. Probably more common to buildings you review are the 50 to 99 year. A lot of residential, commercial, and even office buildings. And then, of course, you have the 100+ year, the permanent, monumental, historical buildings that are going to be around for not only your generation, but many future generations as well. We certainly all know what the codes are today, and most of the time we know what the cost of energy is and other utilities are today, but trying to predict where that might be 25, 50, or even 100+ years from now would be very, very difficult. Certainly we anticipate the cost of energy and the codes increasing in the future, but by how much is a hard thing to know for certain. So sometimes if the project allows it, it would be good to go above and beyond code to somewhat future-proof or plan for the future. Now this one came as a little bit of a shock to me. As a native Texan, buildings use 42% of total energy. I thought transportation would be higher, despite the stereotype. We don't all ride around on our horses here in Texas. We drive around in our big trucks these days, and I thought transportation would be higher. But if you take residential at 23 and commercial at 19, buildings use 42% of the total energy in the United States. In addition to how long a building is going to be around, you also want to think about the building's program. So here on the far left, office buildings, a good number of office buildings, a good amount of square footage, and their energy usage, the orange dot there, is right in line with what you'd expect for that number of buildings and the amount of square footage. Now, if we go over 3 columns, we have healthcare. A smaller number of buildings, a smaller footprint, but goodness, their energy consumption is substantially higher than you would think. But that's because these healthcare facilities are running 24/7. They're running specialty equipment 24/7 to make sure our sick and loved ones are well taken care of. So their energy consumption is significantly higher than a typical building of that size and square footage. Now, on the flip side of that, we have religious and worship facilities closer to the right. Good number of buildings, a nice amount of square footage, but a rather low energy consumption. A lot of times these facilities aren't occupied or fully conditioned 7 days a week. Maybe a congregation only meets 2 or 3 days out of the week, and maybe it's only for a half a day each of those days that they're fully conditioning the building. So certainly less energy consumption there. So again, in addition to how long a building is going to be around, it's also important to think about the program and the activities that are going to take place in that building. Now, I say everything's bigger in Texas, and our energy use is no exception. This data is a little bit old, but Texas has been the leader in the nation for energy consumption for a number of years. California, Louisiana, and Florida often fight to stay second, third, or fourth, but usually all round out in the top 5. So just something to consider as you look at energy usage. Now, section 2, thermal bridging, air infiltration, and moisture control. This image represents a steel stud building prior to continuous insulation. And you can see steel is very thermal conductive. You may have picked up a pot or pan at home. Maybe it was made out of stainless steel, copper, cast iron, all forms of metal, which are highly thermally conductive. As soon as you pick up that pot or pan, it feels cooler than the rest of the room. But if you stick it on your burner, heat up your soup or stew or chili, whatever you're cooking that night, it's going to get warm really quickly. Well, the same thing is true of our steel stud walls. In a cold climate, they're going to try to draw that cold winter in and take your heated interior and draw it out. In a hot climate, like summer, they're going to try to draw that warm summer in and take your cool AC and draw it out. Here we have a thermal camera on the left showing the poor thermal integrity. Certainly, we can see that windows, there's only so much we can do, double, triple pane, IGUs in the commercial world. They're certainly going to be our weakest link, but it's very clear to see where the studs and even the floor lines are causing some thermal bridging in this building. On the right, this is a phenomenon we call ghosting. Now, we're talking about building science today, and ghosting here, what happened? The exterior of the building got wet. It was a cool morning outside, so the heat was on the interior of the building. The heat transferred through the studs and dried up the moisture where the studs are, but where the insulation is in between the studs, there's still quite a bit of moisture on the exterior of the building. A great example of thermal bridging, even without a thermal camera. Now, we've kind of told you and shown you how bad thermal bridging can be, but I bet some folks are numbers people. So let's look at some numbers. We're going to ignore these first two groupings, R13 and R15 in a 2x4 steel stud. Let's focus on this R19 or maybe even R21 in a 2x6 steel stud. Seems to be the most common size studs we see in commercial construction. Well, the effective R value of that R21 in a 2x6 steel stud, assuming 16 inches on center, and don't forget there's a top and bottom track to these stud walls, also made of steel studs, that effective R value of that R21 is reduced to just 7.4. You're losing nearly 65% of your advertised R value in these traditional steel stud wall assemblies. Hence why you have the new codes pushing for continuous insulation. And as ASHRAE defines continuous insulation, it's insulation that is continuous across all structural members without thermal bridges other than fasteners and service openings. So essentially, we know we have to attach cladding through the insulation and back to the studs. We also recognize we have to get things like air, water, and other utilities in and out of the building. So would this be an example of continuous insulation per ASHRAE? We've got our steel studs, we've got a layer of exterior gypsum, we've got some metal Z-furring, we've got the cladding attached to that Z-furring, and then insulation running in between the Z-furring. Wait, what? In between? No, that is not continuous. In order for it to be continuous, it would have to go across the metal Z-furring, or the metal Z-furring would have to be located outboard of the insulation. So we see a lot of times on projects where people believe they have continuous insulation just because it's outside of the gypsum, but unfortunately that metal Z-furring is often a thicker gauge metal than the steel studs, and thus it causes even more thermal bridging than the steel studs. So even if that Z-furring is spaced maybe 32, 48 inches on center, even if you run it perpendicular to the studs, you're still losing roughly 50% of the R value of the insulation between those metal Z-furrings. Now there's some composite Z-furrings on the market. There's some composite products that insulation. You've got your rigid insulation attached to maybe an OSB or a plywood to help support your cladding. But in many cases, you don't even need any sort of extra cladding support. You just have to use the right fasteners and go back to the studs. And there's an entire engineering document that's so widely accepted now, it's actually been in the last 3 revisions of the code, the 2012, 15, and 18. Now, air barriers are also key as well. They've become more and more part of the code, but a little more recently than polyiso and continuous insulation. So it's really no surprise that when we look at the existing building average in America, it's nearly 3 times that of what we would classify as a leaky building. Again, air barriers are really, really new to the code. So the existing building average is not as airtight as we'd like it to be. And there's a lot of potential for air leakage. Certainly service fenestrations, roof and wall joints, doors and windows. Outlets are a big one. You see pictured here is a can light in the upper right. Especially if you've ever done a home energy audit on an older home, maybe one with an incandescent can light. A lot of those incandescent can lights are not insulated above so that they can let the heat from the incandescent bulb escape. They're also often not sealed to the ceiling. So there's a huge opportunity for air and thermal leakage at these can lights. Also, outlets on exterior walls. A lot of times those are not sealed around properly. And sometimes they're also not insulated around properly either. So great opportunity for some air leakage through these different methods. There's a couple of things that assist or cause that air leakage or air pressure difference. Certainly wind, as it blows towards your building, it will push some air in if there's opportunity. And as it comes around the leeward side of your building, it will draw some air out. The stack effect of a multi-story building also has impacts. Combustion and ventilation. I came to appreciate this one a lot about a year ago. I started cooking at home more. I was not, and still am not, a great cook, and I have come to appreciate the large vent-a-hood above my stove. When I burn something, I can quickly evacuate that smell through the vent-a-hood above my stove. Another potential cause of air pressure difference. Now, why use air barriers? Certainly probably the biggest one is improving indoor air quality. They did a study recently of 2 schools, one adjacent to a highway that had an air barrier, and another school 3 miles from the highway without an air barrier. Even though it was located directly adjacent to a highway, it had better indoor air quality because of the air barrier than the one 3 miles away without. You can reduce your building enclosure moisture problems because let's face it, where air goes, vapor is likely to follow, and vapor is liquid or water in the air. Reducing your heating and cooling costs. I can relate to this one pretty well. I was shopping for a new home about 4 years ago, and I went into the new house, and it was roughly the model house, and it was roughly the same size as the one I grew up in. And I can remember my dad coming down in the summer going, "Our electric bill was $400 last month. Make sure to keep the fan and the light off if you're not in the room." "Yes, sir." Well, the salesperson was telling me that this new house, similar size to the one I grew up in, that they could guarantee me that my electric bill or utility bill was going to be less than $200 a month. And I'm sitting there scratching my head going, well, goodness, 20-something years ago, it was twice that. Well, guess what? They're using air barriers on the newer construction. They're using continuous insulation. A lot of advances have been made in how we build and the codes. Energy's not necessarily any less expensive. In fact, in most cases, it's more. But the Department of Energy has stated that 40% of energy to heat and cool a building is due to uncontrolled air leakage. So just by using an air barrier, we can almost cut the utility bill in half. Certainly there are other benefits, reducing greenhouse gas production, even potentially increasing your acoustical isolation. So variety of great reasons to use air barriers. Now, a lot of people confuse diffusion with air leakage. Vapor diffusion is the way in which vapor makes its way through a material. And you can see here, given these conditions, you get roughly half a quart of water would diffuse its way through this wall assembly. But if you have a small hole, just 3/4 of an inch by 3/4 of an inch in that same wall assembly, nearly 60 times as much water would make its way through that hole. So it's really important that you make sure your air barrier is continuous and free of punctures and holes. Now, we all know moisture can damage a building. WRBs have been in the code for a long, long time. No need to argue that one. Certainly one of the most challenging points is flashing around doors, windows, other through wall penetrations. So make sure we get those details right.
What's
So
that?
what if there was a system out
Flashing
there?
windows? Hold on. Have you looked at some new construction in Texas? Are you sure they're even doing that?
Yeah, no, there's definitely areas for improvement. I have the neighborhood I bought into a couple of years ago, they're still building in there, and I walk around and I see a variety of different systems used, and they use the tapes and flashings from the neighboring house's system and vice versa. It's that's one of the hardest ones out there, I think, and that's why there's so many of these photos available. So
Yeah, it probably doesn't give you a whole lot of peace of mind when you walk around and see, well, and if you know, those flashing tapes, well, it shall be applied to material free from dust and debris on a construction site in July in Texas with the wind blowing when we haven't had rain. How's that even
yes.
possible? And then back rolling the tapes with the custom roller and pressure. I've yet to see a framer with a roller back rolling.
Yep.
It's problematic throughout. That's in these field trainings I do. That's one of the number one things I just see continuously missed over and over is the attention to just the head flashing on the window not done correctly, the pan flashing, the WRB details where they join. It's just
Yeah, it's amazing, and with the background in architecture, I'd like to someday design and build my own house, but I think I'd probably either pull all my hair out or it would turn gray. I had a small issue on the house I did buy, and they had to take some brick out, and they were just going to drill holes through the WRB and not do any sort of patching. And I was like, wait, you have to flash around any holes you put, because that's essentially they're like, oh, really? And I'm like, okay, I don't even want to know what else you guys don't know. So,
you know.
But so yes, it's definitely a challenge out there. Education is key. So what if there was a system that could not only be your thermal continuous insulation, it could also be an air barrier and a water resistant barrier, moisture control layer all in one? Well, foil face polyiso with treated board joints and certainly flashing like you would traditionally do around windows, doors, and other through wall penetrations can do just that. An all-in-one approach, continuous insulation, thermal control, air control, and moisture control all in one. And that joint treatment and that flashing, there's a couple different options. Certainly peel and stick tapes and flashings are one option, but there's also liquid options as well. So you can, depending on your particular climate, one might be better than the other, or even the local workforce may have one mastered over the other. So there are options as well. So let's talk a little bit about building enclosure design, performance, and requirements. Everyone's probably familiar with the codes, certainly the IECC, IBC, and even ASHRAE. Maybe you still have hard copies, maybe you're looking at PDFs. Either way, the same information is shared. Now, like I mentioned, continuous insulation has been around for a while. It got its largest leap in the 2009 code cycle with both the IBC and the IECC. You've seen some increases through the 2012, 15, 18, and even the 2021 versions of those codes. Now, it will vary a little bit based on which portion of the country you're in, as the climates are certainly different in, say, Miami versus Fargo, North Dakota. Although lately, Seattle, Washington, and Portland, Oregon have had higher temperatures than we have in Dallas and Fort Worth. But going off of historical data, it will vary. So, for instance, we're just going to pick one kind of in the middle of the country. Let's go with climate zone 4, which would be this yellow zone. You know, everything from Washington, D.C., all the way to Albuquerque, New Mexico, and even a little bit up the West Coast. So with that, if you're on, say, the 2018 IECC, you would want an R13 plus R7.5 of continuous insulation for your steel framed walls above grade. And a lot of folks, and especially architects, like to say, well, Matt, my wall's already so thick, this continuous insulation is just going to make it that much thicker. Well, remember earlier, we talked about a lot of our steel stud walls are 2x6 steel studs. And a lot of times that is to fit that R19 or maybe even R21 bad insulation. But with the code, we're only now required prescriptively to have an R13. So in some cases, you may be able to reduce your wall thickness from a 2x6 to a 2x4 to accommodate that R13. And then adding that R7.5, if you use foil face polyiso, you're only going to have to use 1.25 inches. So you lose 2 inches, add back 1.25 inches, and you've actually made your wall 3/4 of an inch thinner with the use of continuous insulation. So there are some opportunities. Go ahead, Jason.
Sorry, while you have that slide up, so I live in climate zone 2, 3, and 4, just because we serve Texas and Oklahoma. I'm shocked that climate zones 7 and 8 still have the same wall. That's just a comment. But
Yep.
but the question is, have you played around on ComCheck much as far as being able to trade off that continuous insulation in steel frame walls, and how picky it is about that?
It's pretty tough with steel framed walls because of the thermal bridging that steel causes. Sometimes you can reduce the amount of CI a little bit, but it's really hard to get around using it at all because of how much thermal bridging is caused by those steel studs. Yeah. But something I do warn people against is, yes, there are trade-offs. You just, going prescriptive path or ComCheck in this case. And I did early on. I had one contractor that just said, oh, this is so new. We don't like this idea. And they actually paid the architect to go back and redesign the building with probably double what they needed in roof insulation and a few other energy tweaks to get around using continuous insulation because it was too new to them. Wow. They've since come back and said, hey, teach us. We recognize this isn't going away. But it is, depending on the version of the code and or which they're following, it is surprising that, basically from climate zone 3 to 8 for the IECC, that it is the same all the way up. Now, ASHRAE does have, a much better looking increase as you go farther north.
Yeah, I'm surprised there's that much discrepancy between ASHRAE. I mean, there's always been some discrepancy, and I don't live in ASHRAE nearly like I live in the IECC, just because the vast majority of projects and obviously you're on ASHRAE if you're on the IECC as an alternative compliance path. But I mean, and 200 commercial projects where I was building official last, I had one that complied by ASHRAE. I mean, it's 99 out of 100 are using IECC and a simple com check. Now, granted, your Dallas, your downtown, your glass buildings and stuff, that's a different deal. But
Sure.
I had a contractor call me yesterday or last week, and he was having a hard time getting a building to comply, and he was using an R19. And that's why I was like, well, do you have continuous insulation? And that was his whole thing. Well, no, we never do that. So, well, since the 2012, you pretty much can't do steel without continuous. And he couldn't get away with a R19 cavity and an R3 continuous. I remember that. He was having to at least bump up from that. But anyway, so proceed. Sorry to interrupt.
No, all good conversations, good points. And that's true. We'll hit on it here in a little bit. You start to have some issues with building science when you start monkeying around with it. Because really these numbers are designed by climate zone so that you don't have issues with vapor and moisture in your wall. And we'll come back to that. I don't want to get too far ahead of ourselves. So air barriers, also similar story, really got their largest leap in the 2012 code cycle and seen increases in the 15, 18 code cycles as well. There's a couple of different ways to be considered an air barrier. There's the air barrier material test, commonly ASTM 2178, the air barrier assembly test, commonly ASTM 2357, or the building test or blower door test. And if you were to look at these numbers, you would think that the air barrier material with the 3 places past the decimal would be the hardest to pass, and the building test, just 1 place past the decimal, would be the easiest. It's actually quite the opposite. The air barrier material test is much like me handing you a piece of paper and asking you to blow through it. It's a very small scale sample. They've actually nicknamed this one the peanut butter test. If you take Jif creamy peanut butter on cheesecloth, you can pass the air barrier material test. Let's hope nobody's using peanut butter as their air barrier. Now, an air barrier assembly test is a little more realistic. We put a window opening in it. Certainly we flash around it, pipe and duct penetrations, cladding attachments, roof and foundation tie-ins, things that you're actually going to see on a job site. So more realistic, hence the assembly. The hardest one to pass, though, is the building test or blower door test. More than likely, you're dealing with at least a 6-sided building, 4 walls, a roof, and a foundation. Probably a lot more. You've got wall-to-wall connections, roof-to-wall, foundation-to-wall connections that make it very, very difficult to make sure that it's continuous and free of punctures. So this one is the hardest to pass and one of the most critical. Hopefully you don't get to this point and already have your cladding up like they do in this one and go, oh, we're not passing. Where is the leak? Because that can be a tricky one to overcome. A lot of folks curious, how can a foam plastic sheathing be a water resistive barrier? Well, first, let's think a little bit about our WRBs. Number 15 asphalt felt is just generally accepted as a WRB. Some of our wraps and membranes are tested as WRBs. And when they test a wrap or membrane, it's to 2.84 pounds per square foot. In order for a foam plastic sheathing to be considered a WRB, it has to go through ICC ES acceptance criteria or AC 71. That test tests to over double what our wraps and membranes are tested. It's tested to 6.24 pounds per square foot. So if you have a foam plastic sheathing that's been tested as a WRB, you have a really good or well-performing WRB. And usually this is in conjunction with your flashing or tapes or joint treatment of some kind. So it's a full system. Now, we hit on this a moment ago, vapor retarders. There's generally 3 classes of vapor retarders. A class 1 vapor retarder, 0.1 perms or less. Things like polyethylene film, glass, aluminum foil, certainly foil-faced polyiso will often fall into that class 1 vapor retarder. You have a class 2 vapor retarder between 0.1 and 1 perms. Craft paper, oil-based paints. Usually to get foil-faced polyiso there, we have to puncture or perforate the foil. Even extruded polystyrene falls into that category. Then you have your class 3 vapor retarders from 1 to 10 perms. A lot of latex or enamel paints, and your non-foil or fiberglass-faced polyiso fall into that category. And so remember I mentioned earlier that, that you don't want to try to cheat those prescribed R values for continuous insulation too much. Well, that's where vapor really comes into the picture. So for years, we were taught that our buildings need to breathe. Anyone ever heard, my building needs to breathe? I bet we all have, at least at one point, and probably some of us still are of the notion that our building needs to breathe. Well, the reality of it is it's not our buildings that need to breathe, it's the people inside of them that we want to breathe. Now, do our walls need to dry? Absolutely. We do want our walls to dry. But should our walls dry outward to the exterior or dry inward to the interior? And if you come from my walls need to breathe camp, then you probably are the assumption that your walls need to dry to the exterior. But the reality of it is which side of the wall do we have any control over? The weatherman can't even tell you accurately what's going to happen on the outside of your wall most days, but we can certainly turn the HVAC up or down. We have things like humidifiers or dehumidifiers so that we can basically do anything we want on the interior. So the reality of it is we should actually dry to the interior, not the exterior. Hence the new building science mantra, build it tight, ventilate it right. Hence why that model home that I looked at could give me 20 years later a home that's energy bill was half of that of the one I grew up in, even though it was the same size and energy costs have gone up. Build it tight, ventilate it right. Don't continuously let all of the conditioned air out of your building. Now, why did we used to have such a high influence? Why did we want these breathable walls? Well, before continuous insulation, with just our steel stud walls, we had those steel studs transferring the interior temperature and coming into contact, usually on the back side of the sheathing, with nearly exterior temperatures. And what happened? You'd get some condensation. And then those permeable walls would dry up the condensation. Not enough to cure bad flashing at windows, but a permeable wall or a breathable wall could dry up that little bit of condensation. But what are we doing now? Well, code requires us to put a koozie or continuous insulation around our building over these steel studs. So if you follow the code prescribed R values or greater, you're going to have enough insulation around there so that the dew point falls within your continuous insulation. So no longer do you have those condensation concerns. Now, if you run a comm check and you try to do trade-offs, you might not have enough continuous insulation for your climate zone. So that's where sometimes architects get into trouble. Well, I meet comm check, you do, but we might also need to run a dew point analysis and check to see that your wall is going to be dry. So just something to think about, probably a little more in the weeds than folks like to get sometimes. Now, what about fire? Fire is another big one. Can anybody on the call name a large-scale exterior fire here in the U.S.? I give you a minute to think on that, and if anybody does, speak up. Most people think of projects outside of the U.S. You know, certainly a lot of projects in Dubai and that part of the world come to mind. There was a particular project called the Torch. It actually went up in flames twice. Seems like they named it very well. Maybe they just didn't construct it as well as they could have. So guessing nobody had any examples here in the US. If anybody did, one that might come to mind is the Monte Carlo hotel fire of 2008. This was a unique one. They were actually welding on the roof. A spark from the welding landed on the parapet, which was a polystyrene parapet behind the cladding, and it caught on fire. And interesting, polystyrene, if you've ever taken a polystyrene coffee cup and dropped it into a campfire, it melts, it liquefies, it turns into lava. Well, same thing happened here. It started to melt. And when it melts, it goes down. So most fires go up a building. This one actually started on the parapet and started to work its way down. Now, unlike a lot of these large-scale fires outside of the US, there were no lives lost in this fire. Certainly some property damage, but more importantly, no lives were lost here. Now, why don't we have a lot of large-scale fires in the US? Because we follow the codes, specifically IBC, Chapter 26, dealing with plastics or foam plastic insulation. And it states that for your typical non-combustible buildings, types 1 through 4, that you should follow NFPA 285. NFPA is National Fire Protection Agency. 285 is essentially a test method for evaluating the spread of fire across the exterior of a building. It simulates a full-scale fire performance test, and it's really important to note it is an assembly test, not a component test. I've helped design professionals put together a set of specs for a public project where they needed 3 of each manufacturer. And the 3 main things that trigger NFPA 285, potential combustible components in insulation, air and water barrier, or even cladding. So all 3 of those had 3 options apiece, giving the contractor 27 different combinations of how they could put this wall assembly together, all of which are NFPA 285 approved and tested. Miraculously, they always pick a 4th air and water barrier. Well, is it NFPA 285 approved as a test? Unfortunately, there's no national database out there right now. You know, if you're looking for a UL time-rated assembly, you go to UL's website and it'll tell you every single thing you can use in that wall and still meet the 1-hour, 2-hour fire rating you're looking for. NFPA 285 isn't there yet. You really have to rely on your manufacturers or a trusted resource to work through that with you. Happy to help in any way I can. I know most all of our NFPA 285 documentation, and I work with other manufacturers through my CSI or other connections to make sure that we're suggesting assemblies that are tested and not just swapping components. So a little more on the test. It's a mock-up of a multi-story building, 2 rooms, one above the other. The lower room contains a window opening, like you see here where the fire is. Here it is in section view. There's 2 fires lit. The first one is lit inside the lower room. The second one is lit just below that window header, essentially simulating what happens when the fire gets out the window and starts to go up the exterior of the building. There's over 65 thermal couples throughout this test. They're measuring temperature. One of the most critical ones is number 11. It's located 10 feet above the center of the window header. If that one reaches 1,000 degrees Fahrenheit, the test fails. If the flames spread more than 10 feet up the wall, the test fails. Not all of these tests pass. Manufacturers learn what does and doesn't work together so they can advise design professionals, code officials, etc. on what does and doesn't work. We don't want one of your projects with our products to end up on the news in less than a favorable light. So we're not going to say, oh yeah, use it if it doesn't work. Just doesn't make good sense for any of us. So make sure that that wall assembly is part of an NFPA 285 approved assembly. So what if there was a system out there that could do all that? It was the continuous insulation, the air barrier, the water resistive barrier, and an NFPA 285 tested and approved system. Well, your foil-faced insulation, treated board joints, flashing at your through wall penetrations, most of the manufacturers can achieve that and have done their NFPA 285 tested assemblies, and that it's allowed to be done with a variety of claddings. Quick comparison of some of the control layers. Polystyrene usually has an R value between 4 and 5. Gave it a yellow rating because there are some higher, there are some lower. Polystyrene does air and bulk water well, right? We put coffee in our polystyrene cups. Fire, it does not do very well at. Like we mentioned, the polystyrene cup melts. Polystyrene in general will melt at temperatures. Really, it starts to soften around 165 and close to 200, it melts. It's very lightweight, so it goes up easy. It's part of an assembly, you still need an air and water barrier, so not the cheapest of the bunch. Now, mineral wool has some R value between 4 and 4.5. Again, not the highest, not the lowest. Does not do great with air and bulk water. It is an open cell material, so it allows air and bulk water in it. It does very well with fire. It's a non-combustible product. Ease of installation and cost are not so great. It's kind of heavy. It can be itchy. It sags. It's hard to get a hold of. It's very expensive to install because you often need clips to hold your cladding on because it's not as rigid as your other insulation products out there. You have Polyiso, has one of the better R values, 6 to 6.5 per inch. Even without a foil facer, it does very good with air and bulk water. Again, it is a closed cell insulation product. In the event of a fire, it starts to char much like wood does. It's very easy to install because it is lightweight. Because it can be an all-in-one approach, your insulation, your air, your water barrier, and in some cases, you can even eliminate the gypsum out of the wall. We see wall assemblies with this Polyiso system save 15 to 30% in your wall assembly costs. Your wraps and membranes, they're not very thick, they're not providing much R value, so the thermal performance is pretty poor. Gave them a red rating. They do well with air and bulk water. After all, that's what they're designed for. A lot of them have asphalt in them, so they're not very good usually with fire. They have varying degrees of installation, pretty easy overall, but they're part of an assembly. They require those additional components like insulation and such in order to be a true and complete wall assembly. So I may be a little biased working for a Polyiso manufacturer, but if you look at these color ratings, I think it's clear to say that Polyiso is the winner. So let's hit a little bit more on Polyiso, designing building enclosures utilizing Polyiso. Again, we're going to focus on steel stud, but these applications can be applied to wood or even mass wall construction as well. So Polyiso, or Polyiso cyanurate as it's often called, usually just referred to as Polyiso. Some folks even just call it ISO. It's a closed cell rigid insulation board sandwiched between two facers. And there's a variety of different facers out there. If you're familiar with it in roofing applications, you're probably familiar with the organic fiberglass facers in roofing. Organic is something we look for in our fruits and vegetables at the grocery store, but in Polyiso facers, it's really a nice way of saying recycled paper. You don't want to see recycled paper in your wall applications. Apparently it's easy enough to replace a roof. It's not so easy to replace a wall. You have to take the cladding off, take the air and water barrier, insulation, so on and so forth. There's also an inorganic coated fiberglass that you'll sometimes see on roofing or on walls, but probably the most common facer is a foil-faced polyiso. And you'll see that very, very commonly in your wall applications. Now, these boards are typically going to be manufactured in 4-foot by 8-foot panels, but there are opportunities to go bigger. If you're utilizing the full system, the air and water barrier, we see a lot of 4-foot by 12-foot boards. That means fewer fasteners, fewer board joints. There's even a white foil-faced polyiso that can be left exposed to the interior of buildings. We see this a lot in warehouses and data centers. I've seen that produced in 4-foot by 30-foot panels, floor to ceiling in a warehouse with only vertical joints. And custom thicknesses, anywhere from 1/2 inch to 4.5 inches. And if you need something in particular, don't hesitate to ask. It can likely be done, even cutting at 16 or 24 inches on center to fit between masonry ties. All things polyiso manufacturers will do to make it easier on you in the field. Now let's talk a little bit about R value. EPS, or expanded polystyrene, typically has an R value of 4 per inch, often made in a white foam board. Mineral wool, typically between 4 and 4.4. We averaged it at 4.2 per inch of R value. Then you have XPS, or extruded polystyrene, commonly manufactured in pink and blue, has an R value of about 5 per inch. And then, of course, polyiso with foil-faced varieties, you get upwards of 6.5 per inch. So you can see there, at 2 inches, you're an R13 with polyiso and an R10 with its next closest competitor, XPS. So 30% more R value in the same thickness. Other areas polyiso is going to excel: fire resistance. A lot of folks may be familiar with ASTM E84. ASTM stands for American Society of Testing Materials. E84 is a flame spread and smoke developed test. The two major classifications are Class A or Class B. There's also a Class C, but that's usually more for furnishings and things like that. For building materials, you're often going to see them classified as a Class A or Class B. Class A is 25 or less flame spread, 450 or less smoke developed. Class B is 75 or less flame spread, 450 or less smoke developed. And while XPS claims to meet Class A, let's look at this test. So on the right, you have the Steiner tunnel test, and you see the windows down the side of the tunnel. We attach the specimen to the ceiling. This test was designed around wood. And so we attach the specimen to the ceiling and light a flame on the floor. And then we watch to see how quickly the flame or the smoke spread down the tunnel through those windows. Well, remember what we said earlier with polystyrene. Your XPS is a polystyrene. It's going to melt in the event of a fire. So what happens here is the XPS gets hot, catches on fire, and it falls to the floor. It melts, drips to the floor. Well, the way this test is written, testing of materials that melt, drip, or delaminate to such a degree that the continuity of the flame front is destroyed result in low flame spread indices. Well, essentially, as soon as it falls to the floor, or they stop the test. It's just the way the test was, because wood didn't fall to the floor. It charred and stayed on the ceiling. So not all the tests are perfect. Some people like to say ASTM should stand for another silly test method. In this case, I might agree. But per the testing, XPS does meet a Class A. Now, I will say they do things a little bit different in Canada, but doesn't seem like many people have moved there lately. So, just to give you an idea, though, if you were to look at what they do in Canada, if you ignore the fact that the fire has gone from the ceiling to the floor, their flame spread would be over that of a Class B, and their smoke developed would be over 500. So just something to consider. Now, we talked about ASTM E84, but let's also hit on NFPA 285 quickly again. Polyiso is going to outperform there as well. Your polystyrenes, they can achieve NFPA 285 with some of your masonry claddings like brick, stone, and stucco. But a lot of buildings today have some metal or aluminum, maybe cement board siding, terracotta, etc. on them. Polyiso can not only be used in NFPA 285 assemblies with brick, stone, and stucco, but virtually the full gamut of claddings: ACM, MCM, terracotta, metal skin, cement board siding. The list goes on. So you're not limited to just your stone veneers or your masonry veneers like you often are with polystyrene. Polyiso can do it all. Furthermore, exterior gypsum can be optional with polyiso. If you need a UL time-rated assembly, absolutely keep your gypsum. But with polyiso, there may be an opportunity, if you don't need a UL time-rated assembly, to eliminate the gypsum, because it is going to be your air and water barrier if you treat the joints and use foil face polyiso. Another advantage with polyiso is a lot of times the mineral wool fire stops around your header openings are not required with polyiso, whereas they are usually with XPS. So some huge advantages for fire and R value with polyiso. Also, some environmental benefits. Through the years, it's become more and more environmentally friendly. Certainly the CFC, HCFC, and HFC-free blowing agent. Some folks on the call may remember from times in the 70s and 80s when polyiso insulation had R values in the 7s. Well, certainly we've not got that anymore, but it is because we have made it more environmentally friendly. Zero ozone depletion potential, negligible global warming potential. There is some recycled content in these products. Another advantage is if you can eliminate that gypsum, or even if you need the gypsum and you just eliminate that full coverage air and water barrier, you can often save, quite a bit of plastics used in the air and water barrier. I think it's something like 40,000 plastic bags for every 10,000 square feet of full coverage fluid applied air and water barrier that you're eliminating if you use the foil face polyiso with treated board joints. Some other physical properties about polyiso: it has a variety of compressive strengths, usually 16, 20, or 25 PSI compressive strengths. You see it a lot in walls. People will be looking for a 20 or 25 PSI compressive strength. It's dimensionally stable. It's not going to melt, drip, or delaminate like your polystyrenes. And it's a moisture resistant product. It's closed cell, less than 1% water absorption by volume. Some of your mineral wool products will also claim a low water absorption rate, but you also have to understand their test for water absorption is much different than that of a polyiso or even polystyrene. Polyiso and polystyrene, they're submerging their samples below water. Mineral wool is setting their sample next to a cup of water and not absorbing much water through the air. So very different test. So make sure you're comparing apples to apples and not apples to bananas. It's easy to specify and install. You can achieve your CI requirements. Opportunity to increase your interior square footage with a thinner profile because of the higher R value, or you can get more R value in the same square footage. Like I mentioned, a wide range of thicknesses available, anything from a 1/2 inch to 4.5 inches. If you need more than an R31 at 4.5 inches, you can double layer it like they do in roofing. It's lightweight, less than 2 pounds per cubic foot, very easy to pick up. Any sort of fine tooth saw blade will go right through it. Hand saw, skill saw, table saw, whatever you got. Variety of installation methods, everything from a screw and washer, like Jason mentioned earlier, cap nails, a lot of different opportunities. If you're on a job site and need something specific, let us know. I've got a whole host of products I can share with you there. Specifications, They did update ASTM C1289 to include Type 1, Class 1, or Class 2 in the last rendition of 1289. Looking forward, there's the Architecture 2030 Challenge, and like a good set of condocs, it seems like that last 20 or 30% is the hardest. The devil's in the details, as they say. Well, our goal is to be carbon neutral in 2030. We weren't quite to 70% in 2015, and here we are halfway through 2021. We're still not to 80%. We're still not even at 70%. In fact, the last Department of Energy study I saw said we're closer to 50% of the way there. But that's all right. All the design professionals are going to get together December 31st, 2029. We'll stay up all night and pull an all-nighter, right? Oh, okay. Maybe that's just how I finished a lot of projects in architecture school. There are also some lead opportunities through Polyiso. I encourage you, though, to work with your local manufacturer and get a project-specific lead letter, because it will vary from manufacturer to manufacturer, product to product, and even some based on the thickness of the product you're looking at in what percentages can help you out there. So that's going to conclude the presentation. I'm going to open it up to any questions we might have held to the end. Jason, or
yeah. I didn't have any come in. I was going to give you a second to just for the code officials on here, just to, and I'm sure or any contractors, or for all 30 of you that are on here, dealing with your builders, whether it be through enforcement or if you're a sub or whatever your relationship may be. And maybe I hopped on and checked an email on my phone and missed it. Did you mention your structural Polyiso with what we were talking about before the webinar started?
No, I didn't. We also, especially for this particular presentation is really focused around the steel stud applications, but for wood stud applications, especially on our single family homes, which gosh has just exploded over the last 18 months. And even in multifamily, we're starting to see this more. We have a product called our Therma Sheath Si, which is a Polyiso laminated to a fiberboard, similar to like T-ply, if you will. So it gives you the same shear and racking strength that you get out of 7/16 OSB. Certainly you want to fasten your cladding through it and back to the studs. But in addition to giving you that shear and racking strength, it also gives you continuous insulation, which if you're in climate zone 3 or 4, prescriptively is required per the code. If you're as far south as climate zone 2 in southern Texas, it's not necessarily required by code. But it's great because it's kind of an all-in-one approach. It gives you that structural value, the continuous insulation, and because it's a foil face on the exterior, again, you treat the board joints and you flash around your doors, walls, and other through-wall penetrations, and you get an air and water barrier that's continuous as well. And, certainly we had a good number of builders and even production builders using it and have been using it for the last decade. But when OSB and plywood just quadrupled in price over the last 18 months, we have seen demand for that product just skyrocket. So it's very, very popular. And I get it, as code officials, there's some concern. Hey, wait, I don't know about this. Does it really meet structural code? That's one that we actually, rather than go through ICCES report, we went to a competitor to ICCES, a group called DRJ, and they are a engineering review committee, and they actually will put their professional engineering stamp for Texas, Oklahoma, whatever state we might need it in, certifying that the structural value as well as the code values are going to be there. And so that's actually helped tremendously because that's, code officials don't necessarily have the ability or the desire to be design engineers, right? And so having that stamp of approval from a PE really helps us in a lot of cases. And that's just been a huge success, really for a while, but certainly as home demand has gone up and the price of OSB has skyrocketed, that's been a big advantage for folks. And, not only does it give them their structural for less than what they're paying, it gives them the continuous insulation and the ability to be the air and water barrier. So very similar to the presentation we just covered, but for wood studs, it can also be an air and water barrier. And some of the builders will use it 100% around the house, the structural board, the Therma Sheath Si. Other folks will say, you know what, I'm actually going to run the engineering calcs, and okay, traditionally I would need, 3 or 4 sheets of OSB on this wall, so I'm going to use 3 or 4 sheets of the Therma Sheath Si, and then I'll infill the rest of the wall with just what we call our regular Therma Sheath, which is the insulation without that structural board attached to it. And so it's a very economical and energy efficient way to meet code and kind of get around some of the cost increases we've seen with somewhat traditional building materials like wood structural products.
Well, and just to me, that's an absolute win-win, no-brainer, because not only are you getting the structural, but you're saving a little money probably from your framers, because they don't have to go back and wrap the OSB in Tyvek, because it's got the what is the fastener details and fastener requirements for that product? Because I just think that's we got to get that product out there more.
Certainly. So you can either fasten it with staples or nails. It is a little more, if you will, more fasteners than your traditional OSB. It's, believe every 6 inches around the perimeter and then 12 inches in the field. So, a little more fastener intensive than your traditional OSB or plywood, but, nothing too crazy. And they get used to it real fast. In the neighborhood I live in, there's a couple of builders utilizing our product or the competitor's version of it as well, and it goes up really quickly. So.
And you tape, or is it a fluid applied on the seams? What do you do with the seams?
In residential, they typically just use our R-Seal construction tape for the board joints or the seams. And the cool thing about that product is it comes in 4 foot by 8, 4 foot by 9, or 4 foot by 10. So, they are able to hit those floor to floor plate heights, based on the different, you do want that board to be installed vertically with the 8, 9, or 10 foot going up and down. That's one of the big differences, being that it's a structural product, that's where it gains a lot of its structurability. With the steel studs, like we covered in today's presentation, those are usually installed horizontally, which, can help you see where the stud lines and such are as you go up a building. So.
Awesome. Well, good stuff. And I'll include just a little PDF so everyone, of course, you'll get a PDF of the slides. And then I also want to include a PDF of that product Matt's talking about, just because, again, I think with OSB the way it is, and not only that, if anyone has moved to the 2021 energy code, you in climate zone 3, you're not going to be able to do that R15 bib wall, and you're either going to need a 2x6 wall or you're going to need some continuous insulation. It's getting tougher and tougher to get by in climate zone 3 without continuous. And shoot, if you don't need Tyvek and it's cheaper than OSB, to me, that's just an absolute home run. So Matt, how do you follow tech sports at all? How upset were you when Beard went to Texas?
I was not happy about that at all. It seems like we lose some of the things we breed a lot of good out of Texas Tech, and other people like to capitalize on that. So,
well, I was mad until I found out he was a Texas alum, and then I think fair enough. If you go back,
I guess.
But I sure was enjoying March Madness for the last Well, COVID kind of gypped us last
Yeah.
year. Anyway. Well, thanks so much for the presentation, Matt. I did have a couple of other comments, but it was just telling you nice job. I do want to get you, next time I'm up in the DFW area for some field training, if your calendar fits and you can join us out in the field for an hour or two that day, that'd be fantastic. It'd be nice to meet you in person.
Absolutely.
Awesome.
Yeah, let me know. I travel all over Texas, Oklahoma. So, don't hesitate if you're doing one, not even in DFW, I might be in San Antonio when you're in San Antonio or what have you. So,
okay. Well, I live in San Antonio. So if you're ever doing anything in San Antonio, let me know and I'd be happy to meet you out on a job site or however, go sit in one of your presentations and listen to you schmooze the architects or whatever it may be, or heck, I built a cantina bar in the backyard. You can just come over and have a beer.
Excellent.
Sounds
we can
good.
relive our college days.
Yes, sir. Well, thanks for joining us, everyone. Going to finish about 15 minutes early. Well, heck, you know what? Go ahead and take the rest of the day off. Tell your boss I said it was okay. Thanks again, Matt. I appreciate it. And we will, I don't have another webinar scheduled, but we will get one scheduled here pretty quick and I'll send it out and let you know. Fill out the course evaluation for your CEUs. Thanks again, Matt. Bye, everybody. We'll talk to you soon.
Thank you, Jason. Have a great day.